All right, let's pick up where we left off. Unit 2, primary treatment. Not preliminary, primary. It's the step after preliminary. Sedimentation and flotation. Learning objectives. In this segment, we're going to explain sedimentation and flotation principles, list factors that indicate when a clarifier is not performing properly, and we're going to go over a little bit of math. Okay. Well, the math is so you can learn your detention time, your weir flow rate, servicing, surface loading, and solid loading. Okay, let's see here. Sedimentation. Sedimentation is the removal of heavier solids and grit. Flotation is Flotation is the removal of lighter solids and grease. So like when you do the aeration, all that organic material goes to the surface and all your heavy stuff goes to the bottom. Like we saw with the grit example when we covered grit. Types of units. There are three types of units in the preliminary treatment process, or in the primary treatment process. Primary clarifiers. The flotation units, combined sedimentation, digestion units. In your own words, define sedimentation. I would say sedimentation is the stuff that sinks down to the bottom, right? Like when you introduce your polymer and it floats around and collects what it can and sinks to the bottom to make it heavier. So sedimentation is what sinks to the bottom. In my own words, define flotation. Well, it's all the lighter stuff that's lighter than water that goes to the surface. Settling characteristics. Settling characteristics are dependent on three factors: specific gravity, weight of the particle in relation to the weight of equal volume of water, particle size and shape, and relationship of downward movement of a particle to forward flow velocity. Like I said, it's the stuff that sinks down. Which factors will influence settling characteristic? Temperature, detention time, short circuits, weir overflow rate, surface settling rate, and solids loading rate all influence the settling characteristics of wastewater. Temperature. Water expands or becomes less dense as temperature increases above 4 degrees Celsius and contracts or become it contracts or becomes denser as temperature decreases. The opposite is true for below 4 degrees Celsius. Generally, as water temperature increases, settling rate increases. As temperature decreases, so does settling rate. It's like if you try to make tea in cold water, it doesn't work as well as with hot water because hot water becomes more absorbent. It combines more easily. Okay. As water becomes denser, density differential between water and solid particles become less and particles settle slower. So let's go ahead and scroll down. Detention time. Wastewater must remain in sedimentation basin long enough for solid particles to fall to the sludge layer. And that generally takes 2 to 3 hours. Detention time calculations based on flow and tank dimensions. And this is the formula they want you to use to determine your detention time. It's the tank volume in cubic feet times 7.5 gallons of cubic foot, because there's 7.5 gallons of water in a cubic foot. That's not explained here, but that's what I've discovered. All right. Times 24 hours a day divided by your flow rate. Uh, to get volume, it's length times width times height. Always. The confusing ones that throw a lot of people off are the circular ones, but it's pies are square is how you get your area, and then you multiply it by the depth or height. Depth and height are the same thing in a three-dimensional object. Okay, so we're gonna cover some math real quick. I went and wrote this up yesterday, so we're gonna go ahead and use that example because, you know, I already have it done, but I'll walk you through step by step with it. All right, so this is that practice problem we were talking about. All right. This is the grid coverage I wrote up yesterday. But this is the math that covers up the detention time. Detention time is calculated by using volume divided by the flow rate. So let's walk through this practice problem for finding the detention time with a flow rate of 2.5 million gallons a day in a circular clarifier with a diameter of 60 feet and a depth of 12 feet. For the first step, we're going to find the area of the clarifier. To do so, we're going to use pi multiplied by the diameter times the diameter over 4. So when you write it out, it should look like this. 3.14 times diameter divided by 4. Oh, sorry. This line interrupted that. Okay. So that's all over 4. Let me go ahead and tab that. Oh, well. Anyways, that 4 should be right there in the center. For some reason, it's giving me issues when I try to hit space. It wants me to use tab to get it to move over, but tab is too far. Yeah, so all this divided by 4. Quick note. 3.14 divided by 4 is 7.85. That is a constant. And if you want to expedite this, you can just use 7.85 times diameter squared. So, but we're going to use the pi because that's the one they want us to use. All right. So, 3.14 times 60 gives you 188.4 times 60 again will give you 11,304. When you divide that by 4, you get 2,826. That is our area. And then when we multiply by the depth of our height, or height of 12 feet, which looks like 2826 times 12, that'll give us 33,912 for our volume in cubic feet. Now we can do the final step of getting our detention time, which is its own equation of the volume times 7.5 times 24. There's 7.48 gallons in a cubic foot of water, rounded up to 7.5 times 24 hours in a day, divided by the flow. I think that changed because I zoomed in Yeah. That's why I zoomed in so you guys can get a better look at the math equation, but then that changes everything. That's the problem with text documents. All right. So it looks like this. Okay, so our equation should look like this to get the flow rate. We have our 33,912 times 7.5 times 24 divided by 2.5 million gallons per day. Then we take, we go ahead and run 33,912 times 7.5 to get 254,340. And then we multiply that again by the hours in the day to get 6,104,000, I'm sorry, 160. And then finally, for our last step, we divide our 6,104,160 divided by our 2.5 million gallons per day, and that'll give us 2.44 hours, roughly. There's probably some change there, but we're not worried about it. For our test, always go with your closest answer because they run formulas different, and I'll cover that in a little bit.